So in this video, I'm going to be reviewing with you guys how to combine like terms, and that is an adding step, and we are on page 10 of your packet. And we're going to start out first here with some vocabulary. You guys already know this, that a coefficient is a number that multiplies a variable. So in this first example that I have here in our algebraic expression, 8x minus 5, the 8 is what is the coefficient. Now in the next example where we have negative 12 plus 2a, this positive 2 here is the coefficient. In the example right below, we have a negative 4, that's our coefficient. And in the third example, the number that's multiplying by the variable is this 10. Okay, so our examples here were the 8, the 2 was a coefficient, the negative 4 was a coefficient, and the 10 was a coefficient in these examples over here. Okay? All right, now for terms, let's make sure you guys are okay with terms, what a term is. So in the first example, I'm going to box our two terms. We have a positive 8x and we have a negative 5. So these are our two terms. In the next example, we have a negative 12 as a term and we have a positive 2a. We have a negative 11 as a term and a negative 4m as another term. And in our last example, we have a 10x squared and a positive 3. So when we're looking at these two terms expressions, y'all, the boxed number without a variable, that's called a constant. So in this example, the constant would be the negative 5. In this example, the constant would be the negative 12. This constant is a negative 11, and this constant is a positive 3. So if you wanted to list those out, we said that our constants in the example were the negative 5, the negative 12, the negative 11 was a constant, and the 3 was a constant. Now the terms over here, you can just put that those are boxed. Those are the things that I have boxed. Those are our terms. Now the like terms I'm going to explain down here, and we're going to be going through and circling like terms, but like terms have the same variable raised to the same power, and I'm going to explain that part down here in a second. But first I just want to go back and make sure that you're comfortable with the vocabulary here. In the expression 8x minus 5, 8 is the coefficient here in red, x is the variable. There are two parts of this boxed term, and then this term all by itself is the negative 5, that is the constant, okay? So this term has two parts, a coefficient with a variable. This term had one part. Now this is the number that was boxed that was all by itself. Again, that's a constant, and over here the coefficient is 2 with our variable a. This constant is a negative 11, and because we have a subtract 4m, be very careful that you get that the coefficient here is a negative 4. And last but not least, with our 10x squared, we have a 10 with our x getting squared, and then our term all by itself, the constant, is a positive 3. So down here, what we're going to do is we're going to circle all of the like terms with 5j, and the goal here is to say, what are the things that I could combine with 5j? So if I have 5j's, I can't add 7jk's because there's no k here, so those wouldn't combine. But I could take 5j's and subtract 3j's, and I'd be at 2j's. Then I could add a j, I could add a 2j, and I could add a 6j. So these are all of the terms that have a j to the first power. Notice we didn't select j squareds, we didn't select j cubes. We didn't select JKs, we didn't select JKLs, we didn't select constants, we just went after anything that was a J. So what we mean by combining like terms, y'all, is that we're going to go on to say, okay, so if I had these 5Js, 5Js minus 3Js would be 2Js. Now add 2J, add 1J, and add 6J. And so 5 minus 3 was 2, plus 2 is 4. Plus 1 is 5, plus 6, we'd get 11 j's once we combined. All right, now let's move on to 4g squared. So this time we're going after anything that's got a g squared. It could have a coefficient of 4 or 1, it doesn't matter. It could be a positive or a negative coefficient, doesn't matter. We're just going after anything that we can group together with 4g squared. So I don't see a g squared, no g squared. Here's one. Here's a 6g squared. Here's a g squared. And in the second group, there is right there an 8g squared. So what we're saying, folks, is that you can do 4g squared plus 6g squared, that's 10, plus 1 more g squared would be 11g squareds, and now you're going to have plus 8 more, so we'd get 19g squareds once we combine the like terms. Now in our last one, we're just going after like terms with 8, so we're basically just going to be combining constants. That's just like adding or subtracting integers. So what could we add or subtract from 8? Okay, so there's a 3, we have a 14, and we have a -1, and these are all of the constants that we could group together with 8. So 8 plus 3 is 11, plus 14 is 25, now minus the 1, and when we combine those constants, we'd get a 24. So now let's flip over and move on to page 11. And at the top here, what we've got is that we're going to be simplifying each algebraic expression by combining like terms. Now you guys have already been simplifying algebraic expressions. So like when we said simplify 3x squared when x equals 5. You've simply plugged in x equals 5. You've plugged that in right here and gotten a 5 squared, which is 25, and then multiplied that by 3. And so you've simplified algebraic expressions before by plugging in, and then you make them numerical right here, and then you've got PEMDAS. And then when you simplify using PEMDAS, we get our missing total of 75, okay? So now when we're combining like terms, we're not supposed to know what x equals. We're just going to still have an algebraic expression for our final answer. So let's take a look here at some of them. Now, because of the way I have it numbered, I'm going to start out in the video here with questions 1, 2, 6, and 7, and then I'll scroll down, all right? So for number 1, notice we have 3x, and I have a +4 and a +12. So my constants can get combined to be a +16, and there's nothing I can do with the 3x, so we're just going to write 3x plus 16 as our final answer. One thing I want to point out, folks, is that here for step 3, it mentions that the constant always comes last. And you might remember that we want the constant to come last because if this was in our graphing unit and you saw the 3x plus 16, you would know with this constant that the y-intercept is going to be at the +16. So because we want for our functions unit, we want the constant to come last to identify the y-intercept, that's why we're going to have the constant last here, okay? All right, so now I'm down to number 2. Now for number 2, we have a -6x. There's nothing that we can group with that. And now we have a 2 minus -3. And 2 minus -3, y'all, is really the same as 2 plus 3. So that's where I got my +5. Okay? Now over here for number 6, we have 7x minus -6x. And so when we subtract the negative, 7x's plus 6x's becomes 13x's. And then we just write the constant last. There's the +2. All right, so for number 7 here, we've got -3x plus 15x. So that's going to become a +12x, and then you just leave the +1. So you combine x's with x's and constants with constants, and if there's nothing for it to combine with, you just leave it alone in your final answer. All right, let's take a look at some more here. All right, so for number 3, we've got 3x plus 8x minus 4. So these 3x's plus 8x's became 11x's, and then we simply just have the -4. All right, right below it, 8x minus 6x is 2x, and then we have our -32. All right, I think you guys are getting the hang of this. Now for 8 and 9, it beefs up a little bit. We've got 1, 2, 3, 4 terms in the expression, and so we're going to get the x's with the x's, and we're going to get the constants with the constants. So now the 3x's plus 10x's is where I'm getting my 13x's, and now I have 6 plus 14 is +20. And so our final answer would be 13x plus 20. Now for this one, we have 7y's minus 10y's is going to be -3y's. And then we have two negatives. -2 plus 13 is +11. All right, we're going to keep going here. And for these last two, we've got our -3x minus 9x is going to be -12x's. And then, of course, we just have our -5 as our constant. And for the last one here, number 10, I took the time to rewrite it here because we have a minus negative, and that's a +8. So you've got your 4 A's that are negative and your 11 A's. And you can just think of it as 11 minus 4A, and that's how I got this 7A. And then we've got our +8. 8 minus 3 is +5. So that's why the constant here is a +5. So if your answer is positive, your constant's positive, and if your answer was negative, your constant would have been a negative. All right, now let's take a look here at the bottom half of the page. I'm going to leave it like this just because I think at this point a lot of you are getting the hang of this. So if you just want to pause the video and just kind of fill in your answers and then take a look, go for it, that's fine. But a few key things that I'm going to point out in the video now is that right here we have a minus negative. So that turns into +5, which is where I get my +7. Another thing that I wanted to point out is that in number 19. In number 19, you might have realized that we have a -13 and a +13, and the inverse property says that that's going to be a 0. And if that's a 0, the identity property says that I don't have to write that and it would cancel out. So all we're really looking at for this problem, y'all, is the 7y squared, and then you've got your minus 10y squared. And that's where I get my final answer of the -3y squared. If the constant is a +0, you do not have to write it because of the identity property. And you might have noticed because of the inverse property that very quickly you could just slash those out, okay? So that's why the answer is just the -3y squared there. And for number 20, the only thing I wanted to point out right here was that this minus negative is where I got the +5 here. And the -2a squared plus 14a squared is 12a squared. And here when you do 5 minus 7, since 5 minus 7 is a negative number, that's why we have a negative constant here. So that takes care of 11 and 12. And now on page 13, I do want to make sure that you guys are okay with if there is more than one variable in the expression, we're going to organize them alphabetically. So what I mean by that is, in number 21, we have x's, we have y's, and we have constants. Now first I want to point out that we have 1, 2, 3, 4, 5, 6 terms. There are currently 6 terms, and our goal is to shrink it down by combining what we can. So first I'm going to go after the x's. I've got 6 x's plus 2 x's, and that's where I'm getting my 8 x's. Now I'm going to go after the y's because we're going in alphabetical order. So I got 8 y's, 8 minus 1 y, 8 y's minus 1 y would be 7 y's. And last but not least, I'm going to go after my constants. So I've got my +9 minus 11. And since 9 minus 11 is -2, you'll see that I'm writing a -2. So in this section, you want to just make sure that you organize them alphabetically. And in this section down here, when you have more than one exponent, we organize them highest to lowest. So notice in number 25, I see that we have a squareds. Here's an a squared. We also have a's, and then we have a constant. So if I take my 2a squareds and add it to 2a squareds, that's where I'm getting my 4a squareds. And then when I do my 4a minus 12a, 4 of them minus 12 of them is -8a. And then because we have a minus -1, that's the same as adding 1, that's going to be the constant. So I want you to try 26, 27, and 28 by yourself. And I wanted you to try 23, 22, 23, and 24 by yourself. But obviously the video is here for you to check your answers and you can see how you did. And once you're good to go here with page 12, you're now going to flip over and do page 13 as an independent practice. And that concludes this video. Thank you.